All right, here's page 13. We're on number 5. And we did this in class. We used the vernier pressure meter and a syringe, and we determined how much pressure is equal to 1 atmosphere. Now, our sensors weren't perfect. I got these numbers from using DuckDuckGo, as I had described. We got pretty close to these in class, and I mentioned that we were going to have to look these up. So make sure you note these numbers, because that's what we're going to be using. And we said that if we set the syringe to make our sensor read 1 atmosphere, and we turn it to all these different units, these are what we would get. So what that suggests is that everything in this box, all of these are equal. So 1 atmosphere is equal to 14.7 psi, 1 atmosphere is equal to 760 torr, but that also means that 760 torr and 14.7 psi are equal. They're just different scales, just like Celsius and Fahrenheit are different scales. They're both measuring temperature. And in this case, all of these are measuring pressure. They just do it in different scales. Atmospheres is great for thinking about places on the surface of the Earth. Pounds per square inch are a nice unit to think about pounds and a square inch, right? If I draw a square that's about an inch on each side, well, you can think about putting a 14-pound weight on it, and it has a nice visual effect to it. And all of these units have various useful situations. So let's think about how we can use these. One way to do that is to think about them as for every statements. So if we write, for example, for every 1 atmosphere, there are 760 millimeters of mercury. Well, that links atmospheres and millimeters of mercury. And that's a relationship. Since these are all equal, this is a just fact of nature. Since we're measuring pressure, it's just saying, like, for every 32 Fahrenheit, there are 0 Celsius degrees. So we could also write for every statements for all of these. And matter of fact, you're not have to limit yourself to writing everything in terms of 1 atmosphere. You could say for every 760 torr, there are 101.325 kilopascals. That's what kPa stands for, kilopascals. You could also say for every 14.7 psi, there are 760 millimeters of mercury. So let's write out one more of those. And we'll abbreviate for every as FE. So we'll say for every 14.7 psi, TA, we'll write there are 760 millimeters of mercury. So that's another fact we can use. That's another relationship between psi and millimeters of mercury. It's just a standard that exists that we can use to solve problems. And hey, we've got some problems down here. So let's use these two for every statements to solve these problems. It's saying convert these pressures to the specified unit. So they're giving us some number in millimeters of mercury, and they're asking us for atmospheres. What we can also do is write this as its own for every statement, because there's a relationship between this number of millimeters of mercury and some number of atmospheres. So we've got a relationship we can use here. For every 1, there are 760. And now we can ask, okay, well, for every 320, how many do I have? So let's rewrite this as a for every statement. Well, let's put our for every statement down here. And I'll abbreviate again. For every 1 atmosphere, there are 760 millimeters of mercury. And then we can ask the question, for every question mark atmospheres, there are 320 millimeters of mercury. So right here is what we have in our hand. But that's what we're asking. This is like if we're asking, we have 320 millimeters of mercury. Like let's say our sensor is reading 320 and we want to know how many atmospheres. Well, yeah, you can just change the value, but let's say our sensor doesn't read this other type, and that's true of the Pasco sensors. The Pasco sensors don't read all these different values, so you have to be able to convert if that's all you got. So let's say we have this, and this is our standard or our fact. This is our relationship. So what do we have to do to 760 to get 1? Like mathematically, what do we have to do to 760 to get 1? Or vice versa, what do we have to do to 1 to get 760? Well, if you can multiply 1 by 760 and get 760, you can also divide 760 by 760 and get 1. So that's kind of a clue. Like if we divide this by itself, we get 1. What happens if we divide this number by 760? And I should have given you more space. I copied this packet from another teacher. So let me write this up here. 760, and we've got 1 atmosphere. If we go from here to here and we divide, what about when we go 320 to question mark? Well, if we divide that by 760 also, that's just telling us the ratio, the relationship. So 320 divided by 760, 0.42 atmospheres. That would be our answer.